Hello, Algebra 2. Today we are looking at 2.6, the quadratic formula. Our objective is that I can solve quadratic equations using the quadratic formula. Now, solving quadratic equations is something we have done already this chapter. Early on, we talked about how you could solve something graphically and figuring out where it crosses the x-axis. And then more recently, we learned how to solve quadratic equations by factoring. You will notice we're in 2.6 and we did skip over section 2.5, which was learning how to solve by this thing called completing the square. It's a fun and interesting way to solve quadratics as well, but not as useful as some of these other methods, so we decided to skip over that this year. So today we're going to talk about this thing called the quadratic formula. I'm going to skip over this again. It kind of introduces where the quadratic formula comes from. Having said that, it is dependent on knowing how to complete the square, which, again, I just said we skipped, so we'll pass on that. Okay, so the quadratic formula. Again, it's another way to solve a quadratic equation. If it's in the form ax squared plus bx plus c equals 0. So once again, we must have it equal to 0, just like we need to for factoring. Okay, so always get it equal to 0 first, and then you're going to want to write this down. It's x is equal to, so this will give you your solutions for x, negative b plus or minus the square root of b squared minus 4ac. Notice all of that, the b squared minus 4ac is under the radical. And then everything I just wrote, including the negative b, is all over 2 times a. Okay, so it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you might be saying, well, do I have to memorize that? And obviously this year, due to the circumstances, you're using notes. So if this is a year where you could use notes, you obviously don't have to memorize it. Having said that, there are many YouTube videos that you could Google to hear the song that goes with this. It's to the tune of Pop Goes the Weasel. I am not going to make you listen to me sing, but if you are interested to hear that to help you remember it, you could just search quadratic formula song in Google and it'll come up with many different options you could listen to. Now, having said that, let's look at how we can use the quadratic formula to solve something. Here's our first example. Solve the quadratic equation using the quadratic formula. Now, just a tip, every time I go to solve something using the quadratic formula, I like to write it down. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so I write it down. And then I really just do substitution. That substitution is dependent on me being able to identify what a, b, and c are. And we've already practiced this a little bit this chapter. So it's ax squared plus bx plus c. And so everywhere that I see an a, I'm going to substitute in a 3. Remember, it's the number attached to the x squared. So it is just the 3. Please never include the x or x squared as part of it. Okay, so eventually when I go to substitute in, everywhere I see an a, so in these 2 yellow spots, I'll put a 3. Next, I am going to find my b, which again is the thing attached to the x. Don't forget to bring that minus with it, so it will be a negative 4. I'll write that here in a second. But everywhere I see a b, I'm going to put a negative 4. And then last but not least, so that was a negative 4. Last but not least, I need to identify my c. So the c, again, is with the sign. So since it's minus, I'm going to include the negative. And then that's just going to go in this one spot. So my c in this case is a negative 9. Okay, once I identify those 3 letters, then I go ahead and I substitute. X is equal to, now make sure this negative, that has nothing to do with the b, I bring that down. My b, though, is negative 4. So I have a negative 4, which is ultimately going to be positive. Plus or minus square root. Make sure you put the b in parentheses because when you square a negative number, it's going to become positive. Minus 4 times a is 3 times c is negative 9, all over 2 times the a, the yellow is 3. All right, the next thing that I like to do, and I'm going to highlight again here, but separate from what I did before, I like to do this work separately. Tomorrow we're going to learn what that's called and what it can actually tell us just by doing the b squared minus 4ac part. I like to do this as side work though, so that I don't have to keep writing it out. Now, just so you know, if you have your graphing calculator, the TI-84, you can type all of this in one shot. Just make sure you put parentheses around things that you're substituting. If you type that all in, you'll get the same answer, but it is good to know the order of operations. First, I would look at the negative 4 squared. Negative 4 times negative 4 is positive 16. The most common mistake I see students make is on the sign between the 16 and my other 3 multiplications. I have a negative times a positive times a negative. So since 2 of these 3 things are negative, it's going to give me a positive. 4 times 3 is 12. 12 times 9 gave me 108. Okay? So then I do 16 plus 108 and I get 124. So I do that as side work. So now I know that I can just replace all that stuff under the radical with 124. As I'm going, I have a negative times a negative is positive 4 plus or minus square root of 124 over 6. Okay, so these answers can be pretty ugly, and we are going to have to continue to simplify here. Before we do, I just want to talk about real quick when I did the negative 4. Some people think about it as just the opposite of b. So when you see a negative 4, some people just put it in as a positive 4 right away. Either way, just be very careful with your pluses and minuses. Now, we are not going to just type this into our calculator. We are going to continue to simplify and have nice, neat answers, even if it means having a radical in it in the end. Okay, the fact that there's the plus or minus symbol, we'll deal with that later, but that really just means that you could do 4 plus the top, 4 plus the root 124, and divide it by 6, and then separately you would do 4 minus square root of 124 and divide it by 6, and that gives you 2 solutions. Having said that, in this case, we are now going to talk about simplifying radicals. This is a previous skill that we should have, but I realize we don't always remember. So I want to take just a second to do that as a side note as well. Okay, so the next thing we're going to talk about is if I have the square root of 124, this is not a perfect square. Okay, so when I typed it, if I type in the square root of 124 into my calculator, it is not a whole number, it's a decimal. So rather than putting a decimal, we are going to think about 2 numbers that multiply together to get 124. And we want to think about perfect squares. Perfect squares are 4, because 2 times 2 is 4, 9, forgot 9, 16, 25, right? All these numbers are a number times itself. And when I look at 124, I think about 4 because I know that 4 goes into 12 3 times and 4 once. So I know that 124 is 4 times 31. And the reason I show that is because you can take one radical and break it apart as 2 radicals times each other. We did do this a little bit back in section 4 when we were talking about imaginary numbers and radicals, but I think it's important to continue to practice. Okay, 31 is a prime number, so I can't break that apart as another perfect square times something. The reason I do this is because I know that the square root of 4 is just 2, and I can't do anything with square root 31. So this means that 2 root 31 is the same as square root 124, but 2 times the square root of 31 is more simplified. So in my next step, I'm going to take the 4 plus or minus, and I'm going to rewrite the square root of 24 as 2 times the square root of 31. It's still all over 6. Now, last but not least, we have 3 separate pieces here. Okay, so we have the 4, the 2 root 31, and the 6. In order to get this in the most simplified form without switching it to decimals, I'm going to look at these 3 numbers, the 4, the 2, and the 6. And I'm going to decide if I can think of a number that all 3 are divisible by. And they're all even, so I know I can divide each one by 2. And that's what I'm going to do. So I can do 4 divided by 2 is 2. plus or minus 2 divided by 2 is 1. So those are going to cancel. Give me 1. So 2 plus or minus root 31 over 6 divided by 2 is 3. Okay. Now this is one way to write your final answer. Or the other option is we want to see what that plus or minus does. If I want to rewrite this as two separate answers, because it is, I would rewrite it as 2 plus root 31 over 3, and x equals 2 minus root 31 over 3. Okay, so we could write it this way. And then last but not least, we could, in theory, if we wanted to, break it apart as separate fractions. Okay, so this is the same. We talked about this once before. If I break it apart, it's the same as 2/3 plus root 31 over 3. And this one would be 2/3 minus root 31 over 3. Okay, and we talked about that a little bit with our imaginary numbers as well. So all three of those things are actually saying the exact same thing, and it's important just to be able to recognize that. Okay, so the actual idea of the quadratic formula isn't that complex. It's, once you know the formula, it's really substitution. However, you can see that it gets really messy, and doing that work and not making mistakes is where you're going to have to be extra careful. Okay, so that one worked out. It wasn't a nice, neat square, but it was a real number. Now we're going to do another example. Okay, so we're going to use the quadratic formula again. We should be able to go a little bit quicker. As soon as I'm going to solve using the quadratic formula, I write it down. Negative b plus or minus square root b squared minus 4ac all over 2a. And then I go back and I identify my a, b's, and c's. ax squared plus bx plus c. The a is in front of the x squared. There's no number, so it's a 1. The b is in front of the x. It's a -9, and the c is the last number, 27. Okay, so as I look at this, x is equal to negative. My b is -9. Plus or minus square root, b again is -9, put it in parentheses, minus 4 times a was 1 times c is 27. All of that is under the radical, all over 2 times a, which we said was 1. Once again, I like to do under the radical first. If you have your calculator, you can just type it all in one shot. I recommend that. 81 minus. Because I only have one negative in these three numbers, it will be minus this time. And then I do 4 times 1 times 27, which is 108. The problem here is that I'm left with -27. Okay, so when I go to rewrite this, I get a negative times a negative is +9, plus or minus the square root. We just figured out all of this is -27 over 2. Now this goes back to a section 4 concept. So I take the square root of -27. And once again, I'm thinking about my perfect squares. 4, 9, 16, so on and so forth. And I know that 27 is 3 times 9. However, the problem is the negative. So I can break this apart as the square root of 3 times the square root of 9 times the square root of -1. Going back to what we learned, okay, square root of 3, that's a prime number, so it's just 3, square root of 3. Square root of 9 is a perfect square, that is 3. And back in section 4, we learned that the square root of -1 is I. So I can simplify the square root of -27 as 3i times the square root of 3. This is how we would write that. So I'm going to go back here. X is equal to 9 plus or minus. I simplified square root of -27 to 3i root 3 all over 2. Again, before you're done, you do want to look at these three numbers, 9, 3, and 2, to see if they're all divisible by the same thing. They are not, though, because 9 and 3 are odd and 2 is even, so I can't break those apart. So I could actually just leave this as my answer. Or I could break it apart as 9 over 2 plus or minus 3i root 3 over 2. Okay, so I could break it apart as two separate fractions with the plus or minus in between. Or, once again, I could break it apart as two answers. 9 halves plus 3I root 3 over 2, and 9/2 minus 3I root 3 over 2. So once again, this answer, and the combination of these two answers all say the same thing. Okay, I want you to take a minute now. There's two problems here that I want you to try to solve on your own. So pause the video and see how you do. Okay, so I didn't write out the work here, but you should have had x is equal to -6 plus or minus the square root 6 squared minus 4 times 2 times 3 all over 2a. Would have gotten you -6 plus or minus the square root of 12 when you did this first one over 4. 12 was the same as 2 root 3 over 4. In this case, you should have seen that all three of these numbers were divisible by 2, and you could have gotten -3 plus or minus root 3 over 2. Okay, so that's the one way you could have written it. You could have also broken it apart. In the second one, you would have had x is equal to -2 plus or minus the square root, -2 squared, minus 4 times 3 times 7, all over 2 times 3. Would have given you x equals +2 plus or minus the square root. When you did that radical, you should have had a -80 all over 6. When you went to simplify -80, you should have gotten 16 times 5. So it ended up being plus or minus 4I root 5. Anytime you have a negative under the radical, you're going to have an I as part of your answer. Once again, all three of these pieces are divisible by 2, so x equals 1 plus or minus 2I root 5 over 3. That would be where you're at. Okay, last but not least, I want to tie this back to where we started by talking about how we have actually learned how to solve something already like this. Okay, so in this example, it's saying choose a solution method, but it's really talking about why you might want one over the other. Okay, here's the thing about the quadratic formula. It works for any given scenario. So if I take this quadratic equation and I do the quadratic formula, I get -7 plus or minus the square root of -7 squared minus 4 times 6 times -20 all over 2a, which was 6. Gives me +7 plus or minus the square root of 529 all over 12. Now this time, I do want to show this. 529 is a perfect square. It's actually 23. If I take the square root of 529, I get 23 over 12. If you get a number like that, where it's a perfect square, you have to keep simplifying. So I've talked about the option of different ways to write your answers. But if I get just a number here, I need to first do 7 plus 23 over 12, and then I need to do 7 minus 23 over 12. And then I keep going. You add the tops together, I get 30 over 12. 30 and 12 are both divisible by 6, so I would get 5/2. And in this case, I would do 7 minus 23. I get -16 over 12. Both of those are divisible by 4. Hopefully you're pretty good with your fractions. I get -4/3. Okay, so you do have to make sure you simplify to numbers when it is a perfect square. So I wanted to make sure we talked through that part more than the rest. So my two solutions here are 5/2 and -4/3. Having said that, we did learn already this year, earlier this chapter, how to solve this same problem by factoring. And it would work in this case. This is where I would multiply to get to -120 and find two things that add to -7. So we talked about making the table, but then I'd have to go through 2 times 60, 3 times 40, so on and so forth. A positive and a negative until I get two things to add up to -7. So I kept going, and eventually I got to 8 times -15, which is -7. So this was my pair. As you can see, this could take a really long time. As soon as these numbers start getting bigger like this, factoring becomes less efficient. Having said that, it would work as a reminder, because you'll need to know it eventually again. 6x squared, the first term goes in the upper left, the negative 20 goes in the lower right, and this work that I just did, the 8x and the negative 15x, go on the diagonal. Once we set up those terms in the box, then we found the greatest common factor of every row and column. So 6x squared and 8x was 2x. Negative 15 and negative 20 are both divisible by negative 5. 6x squared and negative 15x would be a 3x. And 8x and negative 4 are both divisible by 4. As a reminder, when we did this, basically we have said this is the same as 2x minus 5 times 3x plus 4. But to solve it, we said we would take each factor, set them equal to 0, and solve for x. Add 5, I get 2x equals 5, divided by 2. X equals 5 halves. You can see that that was one of my answers this way, and then subtract 4, 3x equals negative 4. Divide by 3, I get x equals negative 4 thirds. We see that we get the exact same two answers. Now, why would I want one method versus the other? Factoring only works if you get nice, neat numbers, meaning if you're using the quadratic formula, it's only going to work to factor when you get a perfect square under that radical. Having said that, if you get a perfect square there, sometimes factoring will be quicker, especially once you get good at it, but not in a situation like this. Once these numbers get bigger and I have to go through this whole messiness of figuring out two numbers that multiply to negative 120 and add to negative 7, that's going to take me a few minutes. So in that case, quadratic formula might just be quicker and easier. Having said that, you do want to really get good at factoring because you could have a much more simple problem that would actually be quicker by factoring. The advantage of the quadratic formula, though, is you can always find your solutions no matter what the case is with the quadratic. Factoring only works if you get nice, neat numbers as your answer, or fractions. Okay, so that is the end of section 2-6, day 1. I want you to go to your Pearson practice and start doing your 2-6, day 1 Pearson practice. And then tomorrow we're really going to focus on this part under the radical in the quadratic formula, the b squared minus 4ac, and we'll learn what that teaches us on the front end.